over the last couple of years, I have used RTK GPS technology on my mower, and had to learn quite a bit to make all that work. It's getting it's getting more plug and play with ArduPilot, where you don't have to know as much, and always it's been that way, unless, like me, you're trying to do it a slightly different way, whether that's bad or good. But anyway, so I am now trying to work with GPS Y'all, and that has required some additional experimentation and trying to learn kind of how all that works. So anyway, I've connected two GPSes in various configurations, kind of just playing around in U-Center and learning how the GPS connections work for moving base. That gives you that GPS Y'all feature. So I decided I'd record video of some of the things I've played around with here. Some of it's kind of going back to basics, you might say, but that helped me prove at least that all my connections were working, and that I could at least configure the GPSes to do what I wanted to do. And along the way, found a good application note from Ublox that I had never seen before, and it really helped a lot in understanding the messages required between the GPSes and that kind of thing. And so I'm using that to springboard, to what I've been doing. Anyway, so this doesn't directly relate to using the GPSes with a flight controller and ArduPilot, but it's kind of some background information that may be of interest to some people. I also want to have a big disclaimer that I've really probably only scratched the surface with the knowledge that one could have on this, because it's a big field. There's a huge amount of complexity in these GPSes and all the configuration parameters and everything. I only learned what I had to really to make this work, and I certainly don't claim that everything I've done is correct or that my knowledge is right or wrong on this. So that's the big disclaimer. In fact, certainly let me know if you see that I'm incorrect in something or doing something completely the wrong way. But I'm willing to put my neck out there and at least show you what I have got working, and maybe it'll help somebody, give you a good laugh if nothing else. So anyway, here come a few clips of some experimenting with GPSes. Okay, this is just a quick look at how I'm connected. I have a computer that's on my network wirelessly to my shop, which is there, with running remote desktop, or if I'm using remote desktop to be in remote control of that. This is just a flight controller I'm not using right now. I have only anything connected are these two GPSes from ArduSimple. They are both connected by USB to this, using this hub to that PC. In addition, I have a Raspberry Pi that is just being powered from a wall wart down there on my power strip, and this is receiving RTCM3 data from an in-trip server on the internet and feeding that into the GPSes depending on how the configuration I'm testing. So that's the setup. The GPSes each have an antenna. They're not the same. This is a survey grade antenna connected to one of them. The other one is I guess magnetic mount patch antenna underneath that box there. The box is simply to provide some shade for that laptop. That's an old laptop that the keyboard doesn't work on it, but it does a good job as a remote computer like this, where I'm using a keyboard on the other machine. I'm going to look at 4 different configurations. Again, this is not connected to the autopilot. This is really unrelated to ArduPilot. This is just simply experimenting with GPSes in various configurations. So the first configuration will be really just one GPS would illustrate this. It's a GPS with corrections coming in. I happen to have two GPSes, so I just connected them, both to this source of corrections coming from a fixed base. Notice that I'm using UART2. You could use UART1 for this. UART1 typically is used for communication with the device that's using the GPS data, such as the flight controller. And so UART2 is kind of natural to just use for corrections. But that's not necessarily the standard way, but that's the way I'm doing it, so that my corrections are independent of the other communications with the UART or with the GPS that are taking place from the device that's using them. So this is going to be one configuration. The second configuration will be, well, let me go back to this one, and you note I'm not in this configuration. These corrections are coming from somewhere unrelated to my little setup. I actually have them coming from an N-Trip server on the internet through a Raspberry Pi. That N-Trip or the base itself is located at a company where I work, or just retired from, but still doing some work. It's a big space that we have there, and I'm just using it right now. It's about 40 miles, well, 30 miles away. But anyway, that's coming in. This is a serial stream coming in that I need to feed into the GPS. Now, this is not a typo. On the simple RTK2B, for UART2, the line labeled transmit is really the input to the GPS. So you can think of this as being from the perspective of the device that's communicating with it. So you put these arrows to indicate the true direction of data. The TX2 line is a receive line, RX2 is a transmit line. On UART1, it's the other way around, where TX is the transmit, RX is the receive. I might also mention that if you're using something other than this RG Simple boards, I have the Ublox C099-F9P evaluation boards as well. The labels are different for the UART signals on that board. I can provide that for you in a comment below. That board has a little more complexity because it has a wireless connection as well that you need to disable if you're going to use the UARTs directly connected, and not the wireless between the two. But I'm not going to get into too much detail on that. So let's see. The next configuration that we'll look at is where we are generating the correction. So this is a fixed base communicating with a Rover GPS. Now, typically these would not be together on a vehicle. The fixed base would be obviously fixed somewhere with data coming wirelessly to the moving vehicle. In my case, I'm just playing, so I have them physically connected with a wire. They're side by side just on the back of my mower, kind of as a platform for them to be there, where their antenna's already available to connect to and everything. But so this could be a telemetry link. Basically, it's serial coming out here, getting somehow over to some device here that then injects that serial into the Rover GPS. The third configuration is wired exactly the same, but now notice I've got a moving base talking to a Rover. So this is a configuration that gives you accurate heading, having two GPSes on the vehicle. One is sending corrections to the other, and so this one then can calculate relative to this one, it can calculate its location very accurately, and by knowing its location relative to this one, it knows its orientation, so therefore it knows the heading. I hope it explained that well enough. But anyway, if you're watching these videos, you probably know all about that. But this is the moving base configuration. Notice that there's no tie to any kind of fixed base in this configuration. So this configuration does not give accurate location. It gives accurate heading, but not accurate location, because there are no corrections coming from a fixed base. And that leads us to the fourth configuration, which does give us accurate location as well as accurate heading. We still have the moving base giving corrections to the rover, but the moving base itself is getting corrections from a fixed base, and that then lets this know exactly, or pretty precisely, where it's located, centimeter level kind of accuracy. And then of course the heading is accurate because of the other. So and this, obviously this one's location is accurate as well, because it's getting corrected from this GPS, which is being corrected from the fixed base. So if we are connected to this transmit, or this UART, getting GPS information, that is heading and location, they are both highly accurate, which is what we want in a lot of applications and what I'm looking for with my mower. Okay, so let's jump back to config 1. I have connected, let me jump to these photos. This is what I have connected outside. Here are the two GPSes. They are, if you can look at these wires carefully, you'll see they're connected as shown in this in this diagram right here. Now the way I connected this, it turns out that on the Argue Simple boards, there's an XB socket for the XB can be used for the correction information. Anyway, the TX2 line, this is the TX2 line on the Arduino connectors on the board. This wire is coming from my Raspberry Pi, so these are the corrections coming in. But the XB board, this second pin here, also is TX2. So those are wired together. So I didn't have to use a jumper wire or any kind of Y configuration. I just jumpered from here to the TX2 line on the other GPS. So essentially this wire is connected to both here and here. One other quick note is you need to always be careful about this. The Argue Simple board does not know what level logic you're using, whether it's 3.3 volt logic or 5 volt logic, unless the way you specify that is to connect to the IO ref pin either 3.3 volts or 5 volts. Well, it's convenient to grab 3.3 volts from this first pin or this pin on the XB connector. So that jumper is very important, or things won't work because your logic does not have a reference. So you'll see the same thing here. It's wire longer than it needs to be, but that's simply to there. Then other than that, there's just ground connections. Power is coming at this moment, is being provided from the USB connections that are going back to my computer. In fact, this is a little bit larger view that shows the Raspberry Pi with the corrections coming in here. This is a ground wire, and then the computer is closed here, but I'm in remote control of that computer right now. In fact, we're looking at these pictures are stored on that computer. This is a USB hub that lets me have three. I think this has two USB jacks, so I've got a hub so I can plug in a third one for the flight controller later. These GPSes have antennas. One is right here. It's bolted to this piece of plywood, and the antenna cable actually runs through here and comes out. It's connected to that one, I believe. I may be about wrong about that. The other one is the antennas on the front side of this enclosure, and this one is connected to that, or one. They're connected anyway, one to this antenna, one to the other. So that's the setup. Now, if we look, I have U center running twice. It's a nice thing. You can run it more than once. And this one is looking at COM 10. This one COM 11. COM 10 is in. If we go back to our diagram right here, COM 10 is GPS B. which will be eventually will be our base, either fixed or moving base, and COM11 is the Rover at the top, GPS A. So if I look at that now, you'll see they both have a fixed RTK fixed status, because I have them connected as shown here, and I have the configuration so that that's working. Now I'm going to show you how to get to that configuration. That's part of what I really want to do here. So I'm going to reset the configuration. If you click on this, if you look down at the bottom, when I hover over it, notice it says revert to default receiver configuration. So I'm going to click that, and then I'm going to do the same on this one. And I've got them overlapping so we can see them both at the same time, but we'll see the fixed status disappear in a few seconds as it loses or realizes it doesn't have corrections coming in, and the correction information it has is too old for it to reliably use it. So anyway, that'll go away and we will not have fixed. While we're waiting on that, well, I'll go ahead and show you what we're going to be doing here in UCenter. This is not a tutorial on UCenter. In fact, I'd be a poor person to give you that because of my lack of knowledge, but I do know how to do the things I have to do, I guess. We can configure UCenter using Messages View or Generation 9 Configuration View. This is the preferred way for an F9P. But this is the one I have most used in the past, so I still revert back to it sometimes. Notice we've lost our fixed now. That's what I wanted to see. So our default configuration doesn't let us have the corrections coming in correctly, or it's not configured for those. It's something very simple though, as you'll see in a second. But basically we can move around in here under the configuration tree and set parameters and so forth, or we can do it using the Generation 9 configuration view, which I've begun to use more, and I'm going to use that now. The way RTK works, really the way the entire GPS works, is we have ports of various types, and we have messages that we enable to go out those ports, and then on the receiving side, the ports have to have the protocols that we're using enabled for data to come in. So we're interested in the two UARTs, mainly UART2 in this case, and so I'm expanding these to show you the different parameters related, or the setup related to UARTs. Let's look at UART2. The baud rate is at 38.4. The UART is enabled. This one, indicates that. The incoming protocol is set to RTCM3, which is what we want, and the outgoing protocol is set to RTCM3, which we don't care right now because we're only both GPSes are just Rovers that need to have corrections coming in. We don't have anything connected on the outgoing side, but it's interesting that the default configuration does configure UART2 to be sending out that data, at least the port that's the protocol that's enabled. UART1, if you notice, has all the protocols, well, these UBX, NMEA, and RTCM3 protocols coming in and going out. So that's a very busy port by default. It's spitting out a bunch of data. You can see the data that's going on by, well, there's also a USB port. If we look, you see USB has the same kind of configuration settings. USB out protocol right here is what I really want to look at. If we look at USB out protocol, it has all three of those protocols enabled, so it's busy sending out a lot of data, and that's what lets us get all these updates and see the satellites and all that. And we can look at packet console and see the data coming in from the GPS through the USB. This is similar to what would be going out port 1, UART1 I mean, so I want to close that. But anyway, like I say, there's a lot here, but basically to configure certain messages to go out of a GPS, you have to be sure the port you're wanting to use for that has that protocol enabled. So for instance, UART1 out protocol has to have, say we're talking about UBX data, which is the protocol for Ublox, proprietary protocol for its output information. That has to be enabled. But then also under messages out, we have to have just look at all of these messages that can be enabled to go out of that of the ports. They specifically have to be enabled. Now, so you'll notice, let's just pick one. We were talking about UBX, so let's come down to some of the UBX protocols. Looks like they're not enabled by default. Let's go back up here to the NMEA protocols and notice this protocol this message GGA. For the I2C port it's enabled, for the SPI port it's enabled, for the UART1 it's enabled, for UART2 it's enabled, and for USB it's enabled. So that means this message is being sent out all those ports, again assuming that the port output protocol has NMEA enabled, and it does. So okay, so we're needing to be sure RTCM3 is enabled to come in to our Rover, our GPS. So it turns out that it is, so everything should be working, but our problem is really simply the baud rate. I have the Raspberry Pi at 115 200 baud. So if I change this baud rate to that and I set that in RAM and set it in flash, these are the items that are going to be set. I just clicked on those settings, so it's ready to click on those buttons, ready to be sent. I click Send Config Changes, and these check boxes mean it went, and if we look immediately, we started getting correction information. We went to float and fixed. So that's the only change we had to make from the default for UART2 to be, to let us have our corrections coming in. fact, so it was working, just wrong baud rate. So over here we need to do the same thing, and we will be fixed here as well. Advanced configuration, and let me resize this a little bit so we can see the entire window. Can't move this, unfortunately, so I can't shrink this area up that I can see anyway. So we just want to go to UART2 baud. It's 38,400. Change it to 115,200. Set in RAM, set in flash, send it, and then watch for it to take effect. There we go. So that's all there is to getting a GPS set up to receive corrections on UART2. Really, it defaults to the correct settings, other than it defaults to 38,400 baud, and unless that's what you have for your corrections, then you need to change it to match your incoming data stream baud rate. And 38.4 is generally considered, I think, too slow to work well for that anyway, so you're most likely going to have it at something higher than that. So that's it for configuration 1. So now we're going to move to configuration 2, which is to look at a fixed base communicating with a Rover. I should have probably labeled this line RTCM3 corrections. That's what's happening here out of the output line, right, which is labeled RX2, from the base to the Rover TX2 line. So I have, at the moment, I went out to my GPS setup and disconnected the RTCM3 coming from the fixed base from the Raspberry Pi that I had in configuration 1. So basically, let me just say, I have it wired this way. I have now got RX2 on the COM10 GPS, which is going to be my GPS B going into TX2 on the COM11 GPS. So if we look at the moment, both the GPSes are just getting standard 3D fixes. They don't have RTK information. Neither one does. So let's take a look at what it takes to have this GPS send corrections to this GPS. Okay, so a little bit of background, and this is kind of chicken and egg, what to talk about first. You know, as I was researching the moving base configuration, I was led to some documents that help with all these things. What we have to do if we were doing this manually is, once we need to be sure our output protocol from here is set to RTCM3, which it is. We need to be sure our baud rate is the same as the incoming baud rate here. And then we need to make sure the correct messages are configured, these RTCM3 messages. And there are places to go find what those are in documents from Ublox. That's what I have done up to this point with my mower that's been working with a fixed base, feeding RTK or RTCM3 to a Rover. But anyway, so in researching the moving base, I found some other documents, but essentially we have to find our RTCM3, here we are, messages, and enable the correct ones. If you notice, there are none enabled that I can see. So we have to go through and manually enable those on the UART2 port. Have to know which ones to enable and enable those messages. Well, thankfully, we don't have to do that manually. If we can find a configuration file that does it for us, we can load from file and then send the changes, and it'll do all that for us. Well, as I was looking for, and ArduSimple provides those files, I believe. There are various places to get them. But as I was looking for information on GPS yaw, at one point or other, I ended up finding this document from Ublox, an application note on moving base applications. And so it's specifically targeted at moving base. But one thing that was nice that I found on page 19, we have a reference to the Ublox GitHub repository where the configuration files exist. And so if we click on this, here is the moving base configuration. That's not what we want. But if we back up a level, we have quite a few configuration files that I like the names I saw here. Base config for C99, Rover config for C99. Now C99 is their development board, but the files generally work for the ArduSimple as well. It's basically setting up the F9P. So Rover config, that's F9H, a different GPS there. Be careful with that one. So I downloaded this entire repository, and here's what we have, those files we just looked at. If we take a look at those, if we look at the F9P base config, for instance, in a text editor of some kind, we see we can kind of understand what's going on here. It's setting in RAM the configuration message out RTCM3X type 1005. So that's message 1005, RTCM message 1005 for UART1, and it's also storing that in flash, so it'll remember it through a power cycle. So you see these are the messages that are being enabled, and these also enable them on USB 1 and some messages on UART1. Anyway, this file appears to be what we need to get our GPSes working together. The baud rate it sets up for UART1 is 460/800. It doesn't look like it changes the baud rate for UART2 at all. So now that we've seen that, we know that file exists. Let's see if we can use that file back over here on COM10. At the moment, our GPS that we're going to make a fixed base out of. So it doesn't matter how all these things are set right now. I'm going to reset or revert to default configuration, receiver configuration, by clicking that icon. That does the trick. And now I'm going to click, let me make this where we can see it a little bit better if I can. I guess I could, okay, there you go, good enough. Okay, we're going to load from file. I'm going to clear the list. That just gets rid of these things that we've already sent. Load from file. And we want the RTK F9P base config. So open that up, and here are those items we just saw when we looked at the text file. All we need to do now is send the config changes, and let's look for a check beside each one that lets us know it was successfully sent. They all were sent. Alright, so this GPS is now sending out the corrections. If we want to see that that's the case, we look at config message out and come down to the RTCM. Notice there's a 1 now on UART1. Yeah, that's something I meant to point out. When we looked at that file, I didn't look closely, but it did not set up UART2. It only sets up UART1 to send the messages. So we could connect UART1 to our Rover and we'd be working now, supposedly. But that's not what I want to do. I want UART2 working. So what I have to do now is look at this and change for everywhere that I see UART1 has a 1, like message 1005, I need to click UART2, change this value to a 1. I'm going to go ahead and just clear this stuff away down here. Click set in RAM, set in flash. Do that on all those, and then click send config changes, and it would set UART2 up to do that. But to do it a little smarter way than that, although I did that a few times, we can fix this file. We could edit this file and have it set up everything as UART2 as well. So instead of just these UART1 instructions, we create identical instructions that say UART2. And in fact, I did that over here under KT. That's my initials. My initials are actually RKT, which is very difficult to work with. I have trouble typing RTK because I want to type RKT. Here's my file. If I look at this file in a text editor, you'll see what I did was copied and pasted the UART1 instructions from that Ublox file, changed it all to UART2. I also, well, that's it, I guess. Yeah. All right. So now let's see what happens if we go back into our UCenter, clear the list, load from file, KT edits. This is the RTCM3 to UART2 config. If you notice there, it brought those instructions in. Now we click send config changes, and it is now set up UART2 to output the RTCM3 data. So it should be doing that. You can see the ones that it put here in those settings. One more thing that I could have also put in that file, but I didn't, is the baud rate. UART2 baud rate, when we reset to factory defaults, it put it back at 38,400. By the way, if you noticed, it still said 115,200 until I clicked on it. It didn't update, so you have to be careful about that in UCenter, that you're not looking at stale data. 115,200 is what I really want. Set in RAM, now set in flash. When I load it, watch over here on our Rover, we should see that start getting corrections if I did things correctly. Okay. Let's see, what do we have over here that's not right? Okay, so we don't have fixed yet, because there's one more thing we have to do, and that is our fixed base GPS has to know its actual location on the Earth accurately, or at least, well, it has to have something to work from as it does its correction. So we could either key that in, or we can use a survey in feature that lets it accumulate data over a period of time and set its location. Maybe it may or may not be as accurate as we need, but at least it'll do something. Depends on how long we let it survey. So we're going to do that. I'm going to go back and do that the way I'm used to doing it. That is a regular messages view. I'm going to come down to config. This is under UBX config T mode 3, and we're going to set it into survey in mode, and we're going to say we want it to run for at least 10 seconds, and be at least 1 meter accurate. Now it may take longer than 10 seconds to achieve 1 meter, but if it achieves 1 meter before 10 seconds, it'll continue to at least survey for 10 seconds. Normally you'd set this for much longer if you wanted high accuracy, but I just want some kind of value. So now we're ready to run that. This I was under config, UBX config T mode 3. But I also, after I send this to the GPS, I can come down under UBX nav survey in and watch the progress of the survey in. So I've got this set up. I'm ready to hit send, which will send that message, which is the command for it to run. Okay, so it's running. If I come down and click on survey in, it says it's in progress. That's how many seconds. It's already got 0.67 accuracy, it thinks. So when it gets to 10 seconds, it's going to say successfully finished. So now it knows where it is. It's able to send out data, and look over on our Rover GPS. We now have RTK fixed. So several things to set there. I should go back and summarize. Essentially, we had to set up the port correctly, and that was easy with this configuration file. And then we had to do a survey in that let us fix our position on the base, and that's it. So this is the configuration we have just tested and set up. Now we're ready to move on to the next one. Alright, so we've completed configuration 2, which was with a fixed base and a rover. We're now going to look at a moving base and a rover. There are no changes to the wiring. The only change now is that this GPS will not be configured as a fixed base, which provides accurate location information if it's located accurately, and knows that in its settings to the rover. Instead, it's going to provide relative position information, but this is moving potentially on the vehicle. But the head, we now will have accurate heading information. So let's look at how to set that up. I'm going to reset. Really, the rover in all these cases stays the same, no changes to the configuration. So if we reset this back to defaults, we would have to change the baud rate to match the baud rate coming from our base, but otherwise everything defaults to having the correct settings. So we're back over here on the base. Right now it's a fixed base providing corrections to the rover. I'm going to revert to default receiver configuration. So in a few minutes or a few seconds that will go away, because we're now, for one thing, our baud rate is back to 38,400, which doesn't match this baud rate, so it's not communicating. It also, if we look back at the messages, we don't have the RTCM3 messages going out either, if we were to look at those in detail. But so this should go away in a second for multiple reasons. While we're waiting on that to do that, let's talk about what we are going to do. We're going to configure this with a configuration file that sets the right messages that are appropriate for a moving base. Now to do that, we're going to go back to our document that we have open here, this document that is the Ublox moving base application note. Well, I'm going to flip back to see, okay, there we've lost our fixed status now that we have reverted this back to factory settings. Okay, so I think a useful section in this document is on page 10, providing corrections between base and rover. This tells you specifically what messages need to be sent from the moving base to the rover. These are the ones that are in the configuration file that's stored out on the Ublox GitHub site that I've downloaded here. But there are a couple things here that are a little confusing to me. It's this statement: if you're already using MSM7 messages and are running at 1 Hz rate, no issues with RF or serial link, you can continue using the previous configuration without the 4072.1 message. Well, it doesn't have 4072.1 anyway, so I didn't understand that. But it then gives this list of messages that have 7s at the end instead of 4s. So it turns out that when I loaded the configuration in, it didn't work. But if I changed the messages to be these, it did work. So let's look over at the files quickly. This is the moving base config directly from the Ublox website. And if I look at that, you see it has those messages that were listed on the page we just looked at in that document. Instead, if I look at this document that I created, this setup configuration file, I just simply changed it to have the ones referenced here, which you notice the only change is everywhere that there's a 4, it ends in a 7 instead. So, and also I added this 4072_1. I believe that was required. I can't remember now what happened if I tried it without that. Maybe you don't need that based on this statement that I don't quite understand. But anyway, this is my configuration file now. I also went ahead at the bottom and had it set the baud rate of UART2 to 115/200, which is what I want, so I don't have to do that. So this file, I think, should do everything for me. So back on our Rover, we are still happily at 115/200. Nothing's coming in that we understand though. Over here we have 38/400 for our baud rate on UART2, and we have the wrong setup or don't have the configuration for the messages going out. We can fix this, however, by loading in our configuration file that sets all the messages correctly and also changes the baud rate. So we'll click load from file. This is the one I created. Moving base config is the one, and well, we will send that config file. Look at all our check boxes, checks, and be sure they're there. Although if you notice what's happened in my right hand side here, we have a fixed status on the Rover, so we know it must have done everything pretty much correctly. Alright, so what we have now, just to recap, is this configuration. Notice we do not have any corrections coming from a fixed base that has a known latitude and longitude, so we don't have accurate location, but we have accurate heading, because this, relative to each other, the GPSs have a high degree of accuracy. This GPS is sending corrections to that one. The Rover essentially knows where it's located relative to the base, and therefore can calculate the heading. In fact, I can go to messages, UBX, nav, rail posnet, if that's the correct pronunciation, if you are even supposed to say that as a word. And this is where the heading information is located that gets passed to ArduPilot or whatever system is using this. So we're on the Rover GPS, and this heading is the heading that I would have if I were standing on top of the base GPS antenna looking toward the Rover GPS antenna. That is the direction that I would look. And in fact, it's 0.7422 meters away as well. And let's see, if I right click on this, this is just in U-Center. When you click on a message like this, it updates at that moment. You see it turn dark, bold while it's reading, and it updates. You can right click and click poll, and it'll go out and read again. Or you can click enable, and until you again disable it, it updates continually. So that completes a look at config 3. Alright, the last configuration we'll look at, config 4, is the same as config 3, except for the addition of corrections coming from a fixed base into the moving base. One thing to note, by the way, many of the instructions on how to set up these moving base Rover setup talk about using a cross cable between the two GPSs on UART2, and that certainly works, but there is no communication coming back from the Rover GPS to the moving base, so you don't really need that wire, at least at the present. I don't know what the future might hold, but there's nothing coming that way, which lets us then use this input for our fixed base RTCM3 data coming in. So obviously it means that the baud rate that we use for this communication has to be the same as the baud rate for this communication, because we can't set that UART differently for its transmit and receive. So I'm using 115/200 baud, and that works fine for everything I'm doing between the GPSs and from the fixed base GPS as well. So I have gone out to the GPS test setup and added this wire back, the one that comes from the Raspberry Pi. In my case, it's bringing the data down from the base, from the internet, and that's all I had to do. If you look now at our Rover, it's got a fixed status, but now so does our moving base. So this is getting corrections from the ground base, this is getting corrections from the moving base. So now we have the best of everything. We have precision location, and we have precision heading. To run through the entire setup very quickly, I'm going to reset this GPS to factory settings, and I'm going to reset this GPS, revert both to default receiver configuration. So the fixed statuses will disappear on both of these, mainly because this baud rate, if I look at the baud rate now, it's back at 38.4. Same thing here on UART2, 38.4. So actually this GPS is able to communicate with this GPS because they're both at 38.4, but the corrections from the ground are coming in at 115/200, so that's not going to work. But there aren't any corrections coming from here to here because they're not enabled, because we reverted to factory defaults. And if we look up at these messages and all, we'd see that they're all set to 0, the RTCM3. So this fixed is going to go away, and this fixed is going to go away. Okay, that fixed has disappeared there, and this one should go away pretty shortly as well. There it goes. So these are both acting as just GPSs getting their data, signals from satellites, and then that's all they're doing. So let's think about what we have to do. All right, first of all, the Rover is pretty simple. Only change there is the baud rate, 115/200. Set in RAM, set in flash, and send the changes. that's all we have to do, because it's already set up for the protocol coming in on UART2 to be the RTCM3. So now we just have to make sure this one is sending that out. Let's see what happens if we change this to 115/200, the baud rate only, if we make that change and send it. Okay, we still aren't sending corrections from this GPS to this GPS because we haven't set up those messages. But look, this GPS now is getting a fixed indication, because this communication is coming in from the fixed base at 115/200, and our GPS has that baud rate set, and it now is able to correct and get correct, accurate location. So this is essentially acting as a Rover GPS with a fixed base, sending corrections to it. But we want to turn it into a moving base to send the corrections over to this one. And so that should be simple now. I'm going to clear this. We should be able to just load from file our moving base config, and I have fixed it so that let's double check, but down here where it's setting UART2 baud rate, yes, it's now 115/200. So if we do a send config changes, once it gets there, it should now be sending corrections over, and look, we have fixed on our Rover. So pretty simple setup if you have the file. And so I went through a lot of talking to just come down to that pretty simple setup. Hopefully it was useful to somebody. If nothing else, it reinforced some of this in my mind, I hope. And next we will work on getting it set up on our to our Pixhawk, and getting GPS yaw working. So the real question is, did anyone really watch this video all the way through? And if you did, I think you need to reevaluate your life. I'm not sure what that you have one, but anyway, I hope it's useful, parts of it to someone, whatever. Let me know in the comments anything you want to let me know in the comments. See you next time on something else maybe more interesting.